let's do another example. And so in this case, we're going to do an application example. So like I said before, there are many applications to using integrals. So here's one of them. So let's say we want to find the price demand equation for a particular brand of toothpaste at a supermarket chain when the demand is 50 tubes per week at $2.35 per tube, given that the marginal price demand function P prime of X for X number of tubes per week is given by this function. So this is the marginal price demand equation. So P prime of X is equal to negative 0.015 e to the negative 0.01 x. And x represents the number of tubes per week. Now it says, I'm not going to write that. So it says, okay, so here's the thing. We want to find the price demand equation for a particular brand of toothpaste at a supermarket chain when the demand is 50 tubes per week. Okay, so the demand is 50 tubes per week at $2.35 per tube. Given that the marginal price for this price demand, or the marginal price demand function is given there on the board. Okay. So now, and that's the first question. So we want to find, now here's the thing. To find the price demand function, we're going to integrate this because the price demand function is P of X. Okay, so this is where we're going to have to integrate this function to find the price demand function. So P of X equals the integral of negative 0.015 e to the negative 0.01 x dx. Okay, so we're going to integrate P prime of X. Okay, well, let's write this, let's pull the constant out. We don't need the constant in this, so this is going to be 0.015, negative 0.015, times the integral of e to the negative 0.01 x dx. Now I'm going to do a u substitution. So let u equal negative 0.01 x, and so du equals negative 0.01 dx. And then so if I divide both sides by negative 0.01, I get du divided by negative 0.01 equals dx. Okay, so now if I do the u substitution, what do I get? I get negative let me do it this way. So I get negative 0.015 times the integral, and now I'm going to do my u substitution, and I get what? I get 1 over the negative 0.01 e to the u du, right? So du is, right? So dx equals du over negative 0.01. Well, there it is, this times this. And then with my u substitution here, I get e to the u, right? So now I can pull this out, right? So let me pull the other fraction out. So now I get negative divided by negative is positive, so I get 0.015 divided by 0.01. times the integral of e to the u du, which then gives me, well, this here is just going to give me 1.5. So this is going to be 1.5 times what? E to the u plus c. Now again, if I distribute the 1.5 to the c, I'm just going to get another constant. So I'm just going to leave it unchanged. So I'm going to end up getting 1.5 e to the u, which is what? Negative 0.01 x plus c. And there is my price demand function, P of x. Okay, so now, the next thing they ask us though says if the supermarket chain sells 100 tubes per week, what price should it be set at? Well, now that we've got the price demand function, now what if the demand is doubled? Okay. By the way, let's check to see. I'm just curious. So here we go. So they said that 50 tubes per week was at 235. I'm just curious. Let's see. So if we do 50 tubes, so 50 times negative 0.01. And we do okay, and then we do okay, let's see here, what do I get? All right. Okay, good. Okay, so now, here's what we have. Okay, so now, here's information that they give us, right? So guess what? Let's use that information to figure out what the constant is. Right? So this is an initial value problem. So we're given this information. So we're going to plug in this information into this function and see what C is. Okay, so let me erase this part. Okay, so now we know the price is $2.35 when X is 50. So 1.5 e to the negative 0.01 x plus c. Okay? And so when I put it into the calculator, I got, what did I get? Hold on. Okay, 0.9, and then I'm going to subtract that amount. So I got 0.9097, so on. So this part here, 0.9097, and so on. So if I take okay. I get 1.44. So I get C equals approximately 1.44. Since we're dealing with pennies, just round it to the nearest penny. Okay. So now what happens is this particular solution is P of X equals 1.5 e to the negative 0.01 x plus 144. Okay, so now we can answer the second question, which is what should the price be set at if the demand per week goes up to 100, so if it doubles. So we're going to do P of 100 equals 1.5 e to the negative 0.01 times 100 plus $1.44. Okay, and so if we do that, then the price should be set at approximately $1.99. And there's the answer. So there's a real world application that's used in price demand functions. Have a great day.